Adding a few more things. Diapers. Obviously, now it's very common to use diapers. Fertility rates are dropping everywhere thanks to educated women who want to have fewer children. Of course, that doesn't mean consumption goes down because each child consumes more. So poor people may have 4 children but consume less than rich people who have 1 or 2 children. So we have to be careful. Nonetheless, coming back to diapers, there is 89 grams of CO2 equivalent in reusable line-dried washed at 60 degrees centigrade in a large load passed on to a second child. So you have to do a lot of things to keep the emissions low for a diaper or to minimize emissions. If you use disposable ones, you get 145 grams of CO2 equivalent. And if you use reusable tumble dried and washed at 90 degrees centigrade because people want to feel safe about diapers when they reuse them, they emit 280 grams of CO2 equivalent. So this is something to be remembered. Just like paper and plastic argument we had, disposable diapers can be environmentally friendly unless you do all these things to reduce the carbon emissions of a reusable diaper. If you are not careful, then you're going to emit much more than a disposable diaper. These are always tricky things to remember. Basket of strawberries. Everybody loves strawberries, but you get out of season tasteless strawberries. 150 grams of CO2 equivalent grown in season in your own country, but if they are from outside, you get 1.8 kilograms of CO2 equivalent grown out of season, flown in, or grown locally in a hothouse. A lot of fruits and vegetables can be grown in hothouses to beat the seasonal temperature weather problems, and this obviously adds a lot to the greenhouse emissions. The amount of yes. So let's jump to a train. Okay. We're just giving examples so that again you can keep track of the range of carbon footprints, right? We went from under 10 grams to 10 grams to 1 kilogram, and now we are 1 kilogram and above. A mile by a train, 150 grams CO2 equivalent intercity standard class, 160 grams CO2 equivalent for the London Underground, which is actually quite carbon efficient, 190 grams CO2 equivalent for a light train or tram, 300 grams CO2 equivalent for intercity first class. So look at the double the CO2 emissions for first class, which is sparsely occupied. So in general, trains are considered to be built with a very high safety factor. So per person weight a train carries is higher than a car, but the trick is that the train will carry a lot of people. But if the weight of the train itself can be reduced, obviously a lot of carbon emissions can be reduced, and there are also factors of how many times it stops, how fast it goes, and whether it's using regenerative braking, where when it's stopping it's using the heat generated by the braking system to recover energy, and so on and so forth. An 18-mile intercity rail journey has the same footprint as a cheeseburger. An 18-mile intercity train rail journey has the same footprint as a cheeseburger, whereas a mile-and-a-half journey on light rail is equivalent to a cup of milk, and milk is not very environmentally friendly either. So public transportation again is very important for reducing emissions, for releasing space from cars and parking and so on. But one has to be careful about the amount of energy required to propel a train down a track. On just a few simple things, it's decided by how fast the train goes. The air resistance goes up with the square of the speed. So as you know, they try to make the trains very aerodynamic and so on, but nonetheless, as the speed goes up, the friction and the drag goes up, so the air resistance goes up. How many stops there are? Each stop wastes energy. The exact amount being proportional to the square of the speed and the weight of the train. Some newer trains reduce the stoppage waste through regenerative braking that I mentioned, a similar technology to the ones used in hybrid cars, which are regenerative braking. Rolling resistance of the wheels on the track, which is low, so it is lower for trains than for cars because of metal wheels and metal tracks are more efficient than rubber tires on asphalt. The rolling resistance goes up proportionally with the weight of the train. So just like airplanes, reducing the weight of the trains, any transportation is very critical. Type of fuel used. Electricity beats diesel because although there are inefficiencies in generating it from fossil fuels in the first place, once this has been done, the train engine can turn almost all of the power into movement. A diesel engine is much less efficient, of course. So electricity is better than diesel, and electricity source again has to be more and more from renewables and not from coal powered plants. Okay, water, this is now a big issue, right? There are many studies showing that the bottled water is not any better than tap water in most places, and in fact it may be even worse in terms of the minerals, etc., that have to be put back in. But of course supply of safe water is not always guaranteed in many places, especially for people who travel from safer countries like mid-latitude rich countries to poorer tropical countries. They have to be very careful. 500 milliliter 16-ounce bottle of water has 110 grams of CO2 equivalent if it is locally sourced and using local distribution. 160 grams CO2 equivalent is the average if you take across the market. 215 grams of CO2 equivalent if the bottle has traveled 600 miles by road, which often happens. There are other issues as well, that hot cities like Mumbai, which actually has a lot of water, gets a lot of cold sodas and drinks and water bottles from places where they are bottled, and water is actually not as abundant in those places. So you're moving water from a drier place to a wetter place because the wetter place is hot and humid. So these are kind of things that are involved in bottled water as well. And then of course there is the manufacturing of the bottles, just like crates of orange juice. You have to worry about the life cycle analysis of the plastic bottles, and of course you see them discarded everywhere. They are not recycled efficiently, and so on and so forth. A bottle a day would add up to 0.6% of the 10-ton lifestyle if you were to do a portfolio and stick to a 10-ton per year lifestyle. Okay, so lots of things to worry about when it comes to bottled water. But one way to make the train journey efficient, other than reducing the weight of the train itself, is to increase the number of passengers. And this is the kind of scene again you will see in India and Pakistan and so on. How safe is it? Of course not very safe, but people do it anyways. And in a sense it is reducing emissions per capita for this train ride, but obviously we want to worry about safety as well. Okay, so we'll come back and look at more things. These are obviously kind of snippets of various things in various ranges of carbon footprints, and it's fun to just go through them and see how each day activities are involving carbon emissions that we know very well, and those that we don't know very well at all. Some that we can control consciously, some that are beyond our control just in terms of the system and the carbon trap that we talked about. Okay.